In question 3 we are told this is a geometric series, so it is up to us to predetermine the leading term a and the constant ratio r to answer question 3.1 to 3.3. So I would also like to point out that question 3.1 is not correctly phrased, since they're most likely meant to ask to determine the nth partial sum, but my interpretation is only for 1 mark, so most likely what they expect of us is to treat this series like a sequence and then determine the nth term. To do that, we start with the general formula for the nth term in a geometric sequence, substitute the predetermined value of a and r, and then we apply the laws of exponents to simplify this in a compact way. I've written 8 as base 2 because there is already a 2 and I'd like to get their exponents added up. These are like bases, if you want to call it that. And so we get the following, and now we can add the exponents to get 2 to the 4 minus n x to the 1 plus n. To check the validity of this formula, we substitute 1 to obtain t1, which correctly gives us 8x squared. Okay, so we'll just check the second term, the rest should fall in place as well. Just to verify, we need to spend a bit of effort, so this gives us 4x cubed, which is indeed the second term in the so-called sequence. Okay, so that concludes 3.1. Question 3.2 talks of convergence, a concept related to summations at infinity. For this formula to be valid, the condition is that the constant ratio must lie in this open interval -1 to 1. So this gives us a hint how to solve our problem. Since we've already determined the value of r in terms of x, this summation converges if and only if r lies in this open interval. This gives us our interval for x, so that this series converges. That concludes 3.2. To answer question 3.3 effectively, recall that question 3.2 has already guaranteed that this value of x is acceptable, since 3/2 does indeed lie in this interval, which is the accepted interval for x. So this question literally comes down to substitution in the infinite summation formula for the geometric series, which, as you recall, the value of a is 8x squared, the value of r is 1/2 x. Since we have also assumed a certain value of x, we now substitute that in, and upon simplification the result should yield 72. And that concludes 3.3.